Hi guys, this is Divyansh Gupta, CAT 1900 Percentiler from IIMpact.mba. For your benefit, I have launched a free course for the CAT 2025 most probable questions. Check the link in description and enroll now for free. Alright, let's start. Question number 1. If the 11th and 8th term of an AP are in the ratio 2 is to 5. So the 8th term is, let's say, 5x. This is 8th term. The 9th, 10th and 11th term is 2x. Now we can see that the difference between these two terms is minus 3x. And if I divide that by 3, I will get minus x as my common difference of this AP, which means ninth term is 4x, 10th term is 3x, 12th term will be x, and 13th term will be 0. So which of the following statements is definitely false? The sum of no three consecutive terms is 0. So the 14th term is going to be, minus x. So the sum of these three terms will be 0. So this is not false. At least one of the terms is 0. Yes, 13th term is 0. So this will also be not false. This is true. So your answer will be sum of no two consecutive terms is 0, because this will be x, this will be minus x, and after that you will have some multiple of x. So the answer will be option number A. Moving on, sum of all terms common to the two sequences 17, 21, 25, and 16, 21, and so on. 17, 21, 25, this is a common difference of 4, and 16, 21, 26, this is a common difference of 5. So the first common term is already given to me as 21, which means that the uh, common terms will form a separate AP, which will be of the form first term 21 plus n minus 1 into the common difference, which will be LCM of 4 and 5, that is 20. So this is going to be the terms for the terms that are common to both of the sequences. This is going to be the sequence, and this will in itself be an AP. Now, I have to check which will be the highest term that will be, part of this common term sequence. And for that, I will check the value of n for which my term is less than 417. So I'm getting 21, then I will get 41, then 61. So it becomes clear that I'm getting, 401 will also be a common term. And then actually 401 will be the last, because 401 minus 21 is 380, which is a multiple of 20. So how many terms will have passed till since then? So 401 minus 21 is 380. 380 divided by the common difference 20 is 19. So if this is the first term, this is 1 plus 19, that is the 20th term. So the common term sum will be sum of this AP, and this will be n by 2, which is 20 by 2 into first term plus last term, 21 plus 401. So that is 10 into 422 or 4220 will be my answer. Moving on. Two series are in the form Fn and Gm, where m and n are both the integers. What is the smallest four-digit natural number which is common to both the series? So I will first find some terms of this series. I will get 12. Then the first term will actually be, I will put 1. So I'll get 22 as my first term. So this is a common mistake. This is not in the AP form. The AP format will be 22 plus n minus 1 into 5. This will be the AP format for this. Correct. Okay. The second term of this will be 27. Now the common difference is going to be 5. So the next term will be 32, then 37, and so on. This sequence will have its first term as 6 into 2, that is 12. So 26 will be the 14 plus 12, that is 26, will be the first term. The next term will be 32. So the common terms will form an AP with the first term as 32, and common difference as LCM of 5 and 6, which is 30. So the terms are going to be 30n plus 2. So I have to find the smallest four-digit natural number which is common to both the series. It will be of this format. So I can see if I put n as 33, I will get 992, which is the largest three-digit number. So I should put n as 34. So 34 into 3, that is 12, 339, 1020 plus 2, that is 1022, or option number A will be the smallest common term. So two sequences are in AP such that the sum of first terms of both the sequences is 100, and x22 minus x21, which is going to be the difference for the AP x, is equal to y99 minus y100, which is going to be minus times difference of y. So dx is equal to minus times common difference of sequence y. So now they are forming a progression of plus y1, x2 plus y2. So x2 plus y2 will be x1 plus dx plus y1 plus dy. X2 is this and y2 is this. Now dx plus dy is equal to 0 because dx is minus dy, which means x2 plus y2 is x1 plus y1, and similarly each term is actually going to be equal to x1 plus y1. So the 100 terms, each of them being equal to 100, so the sum is going to be 100 into 100, or 10,000. All right, question number 5. ABC are three numbers in GP such that the common ratio of GP is greater than 1. 14A, 16B, and 8C are in arithmetic progression, which means 14A plus 8C is equal to 32B. And the GP means that B is equal to AR and C is equal to AR square. So if I put these here, I'll get 14A plus 8AR square is equal to uh, 32 into AR. Now, if I cancel A and 2, 2A from both sides, I'll get 7 plus 4R square is equal to 16R, which means 4R square minus 16R plus 7 is equal to 0. Now, because common ratio is greater than 1, I will take the positive root, which is R is equal to 16 plus under root 16 square, 256, minus 4 into 4 into 7. So this is 16 square minus 16 into 7. So if I take 16 common, this becomes 16 into 9. So the square root of this will become 4 into 3, that is 12. So 16 plus 12 divided by 2a, that is 8. So that is 28 by 8, or 7 by 2 is going to be the common ratio, which means that the common difference of this AP is going to be 16AR minus 14A, and R is 7 by 2. So this is going to be 6A minus 14A, or 42A. So let us check the options. Option number A fits the bill. So the answer will be A. Moving on. AP has the sum of its first n terms as 0, but none of the terms is 0. Then which of the following statement is definitely true? Now, for some of the terms to be 0, if the terms are odd, then one of them will have to be 0, which will be the central term of that AP, because then you will have 0, D minus D, 2D minus 2D, and these sum will correspond to 0. So if odd number of terms are there, one of the terms has to be 0, which means if the sum of the terms is 0, then the number of terms is going to be even, and it's going to look something like this. D minus D, and then this will be 3D minus 3D, and so on. So even terms can give you some of the terms as 0 without any of them actually being 0. So the answer will be n is always even, because you only have two options: either n is odd or n is even. N is odd is cancelled, because if n is odd, then one of the terms will have to be 0. So answer for question number 6 is going to be A. Moving on, 51 plus 52 till n is equal to 5985. So we have to find the value of n square plus n. Now this is going to be sum of first n natural numbers, which is n into n plus 1 by 2, minus sum of the first 50 numbers. So 1 plus till 50 has to be subtracted from sum of first n natural numbers. So this will be minus 50 into 51 by 2. This is given to us as 5985. So if I multiply both sides by 2 and take this negative term to the other side, I will get n square plus n is equal to 2 into 5985 plus 50 into 51. Now this is going to be 0, 1, 2, 8 is 16, so 17, 9, 2 is 18, so 19, and 2, 5 is 10, so 11970 plus 50 into 51, or 255 and 10 here. So 0 to 1, there's going to be 15, and 14520 is going to be your answer for question number 7. Moving on, question number 8. 1 square minus 2 square plus 3 square minus 4 square. All of this is equal to minus s. So firstly, let me club consecutive terms. I will get this as minus 3. I will get these as 9 minus 16 or minus 7. The next would be 5 square minus 6 square, which would give me 25 minus 36 or minus 11. So this is forming an AP, and how many terms will be there? So you have, uh, blocks of 2 are getting converted into one number, and there are how many blocks? 2002 by 2 or 1001 blocks. So the last term, whatever it is going to be 1001th term. So the sum of this AP is going to be uh, n by 2, that is 1001 by 2, into 2a, which is 2 into minus 3, that is minus 6, plus n minus 1, which is 1000, into common difference, which is minus 4. So this is going to be minus 1001 by 2 into 4006, and if I cancel this 2, I'll get minus 1001 into 2003. So I will do this multiplication. I'll get 2003, and then I will get 2003. So this will be 3005,002. This is going to be the number. Minus sign of this is equal to minus s. So minus minus cancel. The sum of the digits of s is going to be this entire digits added. So 2 plus 5 plus 3, which is going to be 10. So the answer for question number 8 is 10. Moving on. A is equal to 1 plus 2 square. This is a GP. B is equal to 1 plus 4 square. This is again a GP. And A is equal to 3B. So A is going to be first term A into common ratio, which is 2. Now the number of terms is going to be, these are n powers plus 1. So n plus 1. 2n plus 1 minus 1 divided by common ratio minus 1, which is 2 minus 1, that is 1. So this is A. This is equal to 3 times B. Now let us calculate the value of B. This is going to be first term 1 into common ratio, which is 4 raised to the power m plus 1 minus 1 divided by r minus 1, which is 4 minus 1, that is 3. So 3 3 cancel. I will get 2n plus 1 is equal to 2 times 2m plus 2. So I converted this 4 into 2 square. So now I can cancel out 2. I'll get n plus 1 is equal to 2m plus 2, or n minus 2m is equal to 1. So the answer for question number 9 is going to be 1. Moving on, sum of first 12 terms of a GP is 6 times the sum of the next 6 terms. So this means sum of the first 12 terms, if the next 6 terms sum is A, then the sum of the first 12 terms will be 6A. So I can write the sum of the first 12 terms as, or rather, let's call these as X so that we don't get confused. So the sum of first 12 terms is 6x, and the sum of the next 6 terms is x, which means sum of the first 18 terms is 7x. So I can write the formula for these two sums for the first 12 and for the first 18. So it's going to be a times a, which is given to us as 32, times common ratio r to the power n, which is 12, minus 1 divided by r minus 1. This is equal to 6x. Now, the sum of the first 18 terms is going to be 32 into r to the power 18 minus 1 divided by r minus 1, which is going to be equal to 7x. So if I divide these two, I'll get r to the power 12 minus 1 upon r to the power 18 minus 1. is equal to 6 is to 7. Now I can resolve this. I can write this as r to the power 6 minus 1 into r to the power 6 plus 1 divided by r to the power 6 minus 1 into r to the power 12 plus r to the power 6 plus 1. This and this will cancel out, and now I will get 7r to the power 6 plus 7 is equal to 6r to the power 12 plus 6r to the power 6 plus 6, which means 6r to the power 12 minus r to the power 6 minus 1 is equal to 0, or r to the power 6 is equal to 1 plus under root 1 square, that is 1, minus 4 into minus 1 into 6. I'm applying the quadratic formula. So plus 24 divided by 2a, that is 12. I'll obviously not take the negative root because then r to the power 6 will become negative. So r to the power 6 becomes 1 plus 5, that is 6, divided by 12, that is 1 by 2. Now, what they're asking us for is the seventh term of the progression, which would be a into r to the power 6. A is 32, first term is 32, and r to the power 6 is 1 by 2. So, this product is going to be 16. So, the answer for question number 10 is 16. Moving on. Sum of the first 15 terms of the series 1 into 3, 2 into 4, 3 into 5, and so on. So I can write Tn as n into n plus 2, which means Tn is equal to n square plus 2n. Now I have to add the first 15 terms, so I will just put a sigma here. This would be sum of the first 15 squares. So that would be n into n plus 1 into 2n plus 1 by 6. That is 15 into 16 into 2n plus 1, that is 31 divided by 6, plus this 2 will come outside into sum of the first 15 natural numbers, which is going to be n into n plus 1 by 2, or 15 into 16 by 2. So this 2 and 2 will cancel. This will become 2, this will become 5, and this will become 8. So 40 into 31, which is going to be 41240, and this will become 15 into 16, which is going to be 15 into 4 is 60. So 16 to 4 is 240. So 1240 plus 240, which is going to be 1480, or option number A. Moving on. Sum of the series 1 by 12 plus 1 by 20, this is equal to S. 1 by 12 plus 1 by 20 plus 1 by 30, so on, is equal to S. Now I can see this as 1 by 3 into 4 plus 1 by 4 into 5 plus 1 by 5 into 6, and so on. These are fractional sums till infinity. I would obviously want to write each of the term as a difference. 1 becomes 4 minus 3. 1 becomes here 5 minus 4. 1 becomes here 6 minus 5, and so on. So this will open up as 1 by 3 minus 1 by 4, plus this will open up as 1 by 4 minus 1 by 5. This will open up as 1 by 5 minus 1 by 6, and so on. These terms will cancel out till infinity. I'll be only left with 1 by 3. So S is equal to 1 by 3, or 72S is equal to 24. So answer for question number 12 is 24. Moving on, question number 13. 342nd term of the series 1, 2, 2, 3, 3, 3, and so on. So you have 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, and so on. Now the number of terms till a particular row is going to be 1. So this is one term only. There are 2 and 2, so 2 terms. Then there are 3, 3, 3, so 3 terms, and 4 terms. So the number of terms till the nth row is equal to sum of first 10 natural numbers, that is n into n plus 1 by 2. Now we have to find which row 342nd term will lie at, or we want to find which is the number of this format which is just less than 342. So if I put n as 25, I'll get 25 into 26 by 2, which is going to be 25 into 13, which is 250 plus 75. So that is 5 to 325, which is very close to 342. If I had put in 26, I would have gotten 351. No, plus 26 on this. Which means that till the 325th term, your 25th row is getting exhausted. 25th row has 25, 25, 25, and so on. The 26th row, which will have 26 terms till 351st term, will have 26, 26, 26 as its term, and 342nd term will be lying in this row only because it is greater than 325 and less than 351. So it will be somewhere here. So the answer will be 26. Moving on. Terms of the sequence T1, T2, T3 satisfy Tn minus Tn minus 1 plus Tn minus 2 is equal to 0. Sum of the first 88 terms and the first 89 terms are 150 and 120. We have to find the value of T1 plus T2 by 2. So immediately I can observe that T89 is going to be 120 minus 150 or minus 30. However, it does not seem to help me a lot right now. So let us decide. We have to get to T1 and T2, but working our way backwards from the 89th term is going to be very, lengthy. So what I'm thinking is the terms should, start to repeat. So from here we can say Tn is equal to Tn minus 1 minus Tn minus 2. So let us say that T1 is equal to T1 and T2 is equal to T2. Then T3 will become T2 minus T1. T4 will become T3 minus T2, which will be minus T1. T5 will become T4 minus T3, which will become minus T2. T6 will become T5 minus T4, which will be T1 minus T2, and T7 will become T6 minus T5, which will be T1. So as we can see, the first six blocks will get repeated because T7 is T1 and T8 will become what? Uh, T7 minus T6 or T2, after which these blocks will start to repeat. So you have blocks of six numbers which are going to get repeated. And the sum of these blocks is T1 plus T2 plus T2. So if we find the sum, you have a negative here, you have a negative here, and you have a negative here. So the sum of these six terms is 0, which means till 89th term and 88th term I have to find the sum. Sum till 84th term, which will be a multiple of 6, right? So you will have some blocks of 6, some integral number of blocks of 6. The sum will be sum till 84th term will be equal to 14 into 0, because you will have 14 groups of 6 terms, each with a sum of 0. So 0. So you are given sum of first 4 terms, that is T1 plus T2 plus T2 minus T1 plus minus T1 is equal to 150, and sum of first 5 terms, which will be all of this minus T2, the fifth term, is equal to 120. So we have to find T1 plus T2 from here. So the first equation will give me 2T2 minus T1 is equal to 150. And the second equation will give me T2 minus T1 is equal to 120. So if I subtract these two, I'll get T2 is equal to 30, and corresponding to which I'll get T1 is equal to 30 minus 120 or minus 90. So T1 plus T2 is going to be minus 60, and they are asking me for by 2. So minus 60 by 2 or minus 30, or option number A. Moving on. Infinite sum S is equal to 1 plus 4 by 7 plus 9 by 7 square plus 16 by 7 cube and so on. So I will first divide by 7. I'll get S by 7 is equal to 1 by 7 plus 4 by 7 square plus 9 by 7 cube plus 16 by 7 to the power 4 and so on. If I subtract these two, I will get 6s by 7 is equal to 1 plus 3 by 7 plus 5 by 7 square plus 9 by 16 minus 9, that is 7 by 7 cube plus 9 by 7 to the power 4 and so on. I still not have an infinite GP, so I will do this process again. I'll calculate 6s by, I will further divide this by 7. I'll get this as 49. This will be equal to 1 by 7 plus 3 by 7 square plus 5 by 7 cube and so on. If I subtract these now, I'll get 6s by 7 minus 6s by 49 is equal to 1 plus 2 by 7 plus 2 by 7 square plus 2 by 7 cube and so on. So this becomes 1 plus 2 common, 2 by 7 common, 1 plus 2, 1 by 7 plus 1 by 7 square, and so on, which is an infinite GP. So this sum will be equal to 1 upon 1 minus 1 by 7, 1 upon 1 minus r. So this will be 1 upon 6 by 7 or 7 by 6 into 2 by 7. 7, 7 cancel. This is cancelled. So this becomes 1 plus 1 by 3 or 4 by 3. So this entire thing is equal to 4 by 3, and this is equal to what? 6s. If I take common, then I'll get 7 minus 1, that is 6. So 6 by 49. So 36s by 49 is equal to 4 by 3. This cancels, this makes it 9. So s becomes 49 by 27, or option number C. Moving on, p is equal to 2 square plus 1 into 2 to the power 4 plus 1, and so on. We have to find this log value. Now the best way to deal with this is multiply both sides with 2 square minus 1. So 2 square minus 1 into p is going to be this side multiplied with 2 square minus 1. Now this 2 square minus 1 into 2 square plus 1 will give you 2 to the power 4 minus 1. This 2 to the power 4 minus 1 into 2 to the power 4 plus 1 will give you 2 to the power 8 minus 1. This will give you 2 to the power 16 minus 1, and so on. So at last you will be left with 2 to the power 1024 minus 1 into this, which will be 2 to the power 2048 minus 1. And this is what? 3p plus 1 is equal to 2 to the power 2048. So the log of this will become, log of 3p plus 1 will become 2048. So multiplying with something so that every new result of the product, combines with the next term, and all of these terms essentially vanish, it is a very useful property. Moving on. Find the sum of infinite series 1 plus 2 plus 7 by 4 plus 5 by 4 plus 13 by 16 plus 16 by 32 plus 19 by 64, and so on. So this is a bit deceiving because initially I can't seem to get a pattern here, because the denominators are same here. So I don't know what is happening here. I might even feel the need to add these and call this as 3. However, after this I see that the terms, the denominators have a ratio of 2. They are increasing with a multiplication of 2, which means initial terms should also ideally have an increment by 2. So let us say if this is 16, this should have been, the denominator here should have been 8. So let me make this as 8. This will become 10. This denominator of 4 is fine. This should actually be equal to 4. Yes, half of 8. So this is fine as 7 by 4. Now the denominator here should have been 2, half of 4. So I will make this as 2, which will change this as 4, and the denominator here should be 1, and that is fine. So I will call this as my sum, and now I can see that the numerators are in AP with a common difference of 3. So I will now divide this by 2. S by 2 will become 1 by 2 plus 4 by 2 square plus 7 by 2 cube plus 10 by 2 to the power 4, and so on. And if I take a difference, I'll get S by 2 is equal to uh, 1 plus 4 minus 1, 4 minus 1, that is 3 by 2 plus 7 minus 4, which is 3 by 4, which is 2 square plus 3 by 2 cube, and so on, which means that my S by 2 is actually equal to 1 plus 3 by 2 taken common, 1 plus 1 by 2 plus 1 by 2 to the power 4, and so on, which is an infinite GP with a sum of 1 by 1 minus 1 by 2, which is 2. So this becomes 1 plus 3 by 2 into 2, 2, 2 cancel. I'll get S by 2 is equal to 4, or S is equal to 8. So option number A. Moving on. A sequence AN is defined as A1 is equal to 2 and AN plus 1 is equal to AN plus 2N. So we have to find the value of A100. So let us start. We'll get A2 is equal to A1 plus 2. Or rather A1 plus, A1 plus 2, 2 into 1. A3 will become A2 plus 2 into 2. A4 will become A3 plus uh, 2 into 3. And if I keep writing this, I'll get A100 is equal to A99 plus 2 into 99. Now, if I add all of these equations, A2 will cancel, A3 will cancel. So everything apart from A1 here and A100 will cancel. I'll get A100 is equal to A1 plus 2 times, this is 1 added till 99. So sum of the first 99 natural numbers, which is going to be 99 into 100 by 2. Now A1 is given to me as 2. This 2 will cancel. So 2 plus 9900 is going to be my answer, which is 9902, or option B. Moving on. Sum of n terms of a sequence is 4n square plus 7n. So what is the sum of 6th and 7th and 8th term? So sum of the terms till 8th term minus sum of the terms till the 5th term should give me term number 6 plus 7 plus 8, because sum till first 8 terms includes sum till first 5 plus these numbers. So I can get S8 as 4 into 8 square plus 7 into 8 minus S5 as 4 into 5 square, uh, you know, plus 7 into 5, which will give me 4 into 64 minus 25, which is 39, plus 7 into 3. Now this becomes 156 plus 21, or 177. All right, next question. 2 by 1 cube plus 6, which is 2 into 3 divided by 1 cube plus 2 cube, plus 12, which is 3 into 4 divided by 1 cube plus 2 cube plus 3 cube, and so on. So if I write Tn, I will get Tn is equal to n into n plus 1 divided by sum of first n cubes, which I know is n square into n plus 1 square divided by 4. So I am getting Tn is equal to 4 divided by n into n plus 1, which means I can say Tn by 4 is equal to 1 by n minus 1 by n plus 1. So I have to find this term. So let us add all of this. I'll get my answer S divided by 4 is equal to 1 minus 1 by 2 plus 1 by 2 minus 1 by 3, and so on. So all these terms will cancel and I'll get S is equal to 4, or option number C. All right, moving on. A naught is equal to 2, A1 is equal to 3, and AN plus 2 is given to me in a recursive function. And we have to find the sum of these 5 A's. So let's find first few terms. A1 is equal to 3. So A2 is going to be 1 plus 3 by 2, which is 2. A3 is going to be 1 plus 2 by 3, which is 1. And A4 is going to be 1 plus 1 by 2, which is 1. Which means A5 is going to be 1 plus 1 by 1, which is 2. And A6 is going to be 1 plus 2 by 1, which is 3. So I can see that the numbers have started to repeat in blocks of 5. Now I could hypothetically go and find the exact value of A2020 and the subsequent terms, but because they are asking me for sum of 5 consecutive terms of this sequence, and the sequence itself is made up of blocks of 5 terms repeated, the sum of any 5 consecutive terms is going to be sum of these 5 terms, because regardless of which you take as your first term, the next 5 terms will give you the same sum. So 2 plus 3 plus 2 plus 1 plus 1, or that is 5 plus 4, or 9 is your answer.